refresher yourself on what we did that day, you'll go on Edmodo and watch that. I'll show you how to access that tomorrow. Okay. So what we're going to talk about, I gave you the key information. I kind of did some color coding because there's some additional things you need to know to make sure you identify and recognize and determine correctly. So we're going to look at lines and planes intersecting. Oops, come back to this. This, in this parentheses right here, these vertical lines, two vertical lines, that's the symbol for parallel. We will, yeah, okay. We will use this symbol. We will not write the word out, so get used to seeing that. We're going to actually do that today on this box. Also, I put in here in red, you must see arrows. If I give you a figure right now, I gave you two lines. They appear to be like they're not crossing. We have line AB or line X, and I have line CD, or I could say line Y. Right now, I cannot assume they're parallel. In geometry, assume nothing. Okay, make sure you have evidence to justify that basically conjecture that you're making. You would have to see, and I need you to draw this to your notes as well. You would need to see an arrow going in the same direction to prove that the lines are parallel. Because I'm going to start giving you figures, I'm going to start giving you multiple lines, and some will have arrows and some will not. So you have to know the relationship with them. Sometimes they do, and I'll just show you. Sometimes anything that has the same symbol has a relationship. So you can, I'll draw it over here. If I wanted to draw another set of lines, let's say I did like this. They kind of look like they're going in the same direction as the ones I did previously. But the minute I do this, the minute I put just a single arrow, I'm saying that these set are parallel, but they are different from this set here. Okay, so it has to have the exact same symbol to have a relationship. Any questions on that? Okay, so add your arrows. Now, the way we would, oops, let's fix that. The way we would actually, never cross. The arrows, they have to have the same set of arrows to show that they're parallel. So like, I have two arrows written on this one. Yeah. As soon as I draw another set of lines with a different set of arrows, like maybe only one, then I'm showing a different relationship. But I'm showing that they're parallel, but they're not parallel to the ones before. The other two I did were parallel to each other, but they weren't parallel to these two sets. Yeah. Now, here, to show it symbolically, because we're not going to write the words, you're going to start seeing stuff with symbols. How do we name this line? What can I name the first line, the top line? AB. So I would put AB. I'll put the line symbol above it, so that's line AB. Now, to show or to denote that this line is parallel to CD, I'm now just going to put the two vertical lines. That's the symbol for parallel, and then I would write CD, and the line symbol over CD. So that makes sense? You'll see sometimes on SAT and ACT, they'll put X is parallel to Y. So they're trying to say that line X is parallel to line Y. So be familiar with the symbol. Now, another type of intersection you can have, that's no intersection, but perpendicular. In this parentheses here, I put an upside down T. That's the symbol for perpendicular. I will not write the word out. You'll see that symbol for now. And you must see the box. So on the figure, you have to see this red box or a box showing that the lines are intersecting exactly at 90 degrees. If you don't see that, you can't assume it. They either have to say it in words, or they have to say it with a symbol. Yes, sir? Yeah. So up here I already went and I said line PD is perpendicular to line EL. I've already gave you the way to show that symbolically. Now, you could have an intersection that's in the same plane, but it's also not perpendicular. So it's not at a right angle. So if you just have a basic intersection, it's in the same plane, but it's not perpendicular. And I'm starting to use the symbol so you can get used to that. So in here it says line AE and line BD intersect at, I know there's not an actual point there, but they want you to be able to read and recognize that where that line intersects would be at point C. That's pretty simple, right? Good. All right, now, you got to do first thing is they are not parallel. I'm going to write it right now, but understand that they're not parallel. Skew, when we're talking about lines, cannot be parallel, not on the same plane, which means they're non-coplanar. Okay, they're not on the same plane, and they never intersect. Okay, they never intersect. Now this might be sometimes difficult for people to see spatially. So what we're going to do is I want you to get a color pencil or a highlighter to start, and we're going to start with a set of lines. Okay, or start with one of our lines. Okay, so I'm starting with line XY. Now, we have basically a rectangular prism here, three-dimensional shape. I have a line that exists through any 2 points. That's a postulate we're going to get to tomorrow. And I know what we really see is just this edge here between X and Y. That's the segment. That's the part of the line. So I need you to understand when we talk about non-coplanar, not on the same plane. So you can highlight this so you can see the relationship. And I'll highlight it too. What I'm talking about first is this line is part of this plane at the bottom. Do y'all agree with that? Can y'all see that? Okay. All right. Now, it can exist that a line can be a part of more than one plane. That we're just going to now recognize the parts of this prism as top, bottom, front, back, left, right. So you can make sure we're identifying the same plane. The line XY or segment XY is also a part of what other plane? Top, bottom, front, side, which one? The front. Okay, do you understand? Basically, where the bottom meets the front is at that intersection XY. That's what happens when planes intersect. They intersect at that line. When it's for you to have skew lines, it cannot be on the same plane. Okay? So if we're gonna start, let's just say we're gonna start at the bottom. I need to pick a different plane to use. Okay? So which plane? Do you want to go to the top, side? Where you want to go? You tell me. Go to top. Okay, so let's go to top. So I'm gonna highlight the top. My top and my bottom are definitely parallel. Okay? But for us to have skew lines, I need to pick a line that exists on that plane that is not parallel to our line XY and would never intersect our line XY. Okay, does anyone see one? Okay, all right, we're gonna show you something. Let's see if you see it now. All right, guys. So here's a line on the blue plane. They're trying to show you that that line exists, right? Okay. I'm just moving that line. I can slow this down so you can see it. Do y'all see? Y'all with me so far? Okay, so when I'm talking about a line that's not parallel, so if you wanted to see, let's say I wanted to see parallel, there's parallel, right? Okay, but these lines are on the same plane. Everyone agree with that? All right, so one way to see non-parallel and not on the same plane and does not intersect, the way that looks, that's what we call skew lines. Now notice what happens, okay? So now look, real quick, I'm gonna rotate this a little bit. Let me do a new line. Let me do another new line. There we go. I like this one better. Okay, so if you look, do you see that this bottom line here is on the plane, the blue plane, if you want to look at it like that way, okay? But this line, what is this line doing? Yeah, is it on that plane? No, what is it doing to that plane? It's going through, okay? It can go through the plane, all right? Now, I could look at it also this way. So let's look at this one. create one that's parallel to that, all right? But if I want skew lines, they cannot be parallel, okay? And they cannot be on the same plane. So that means I have to pick, see what happens here? I pick another line on a different plane, and those lines would never cross each other. So for it to be skew, it has to be non-coplanar, it cannot be parallel, and they can never intersect. Those three things have to happen to be skew. Do you have any? Can you see it a little bit better now? I will. All right, so we have not parallel. That means non-coplanar. Non-coplanar, not on the same plane, never intersect. So if I have this red line here as one of my lines, where would a line be skewed to that exist? SV, yes, SV would be skewed. So I could draw a line right here, and these lines are not on the same plane. They are not parallel, and they would never intersect. Now, there's more than one set of set of skew lines. Okay, I could have put the line somewhere else. Did anyone pick a different location? TX, yeah, TX would work. Yeah, TX would work as well. Y'all see another one? TU would work, yes. Okay. SW would work. Now, the key to make you see this correctly, if I have one line that's horizontal, okay, the other line has to be going in a different orientation. It cannot be horizontal as well. So if one line is horizontal, the other one has to be either vertical or it has to be diagonal. Can you see that now? We're good? All right, so make sure you might want to extend the lines, add the lines to your picture so you have an example of skew lines, or what it means to be skewed. All right, let's finish this up. Planes can be parallel as well. Okay, that means they would never cross. You would still, let's go ahead and add the notation. Guys, on your drawing, you still would need to draw your arrows to show that the planes are parallel. Okay, you show the arrows to show that they're parallel. You can't just do it with lines. Lines are part of the plane, or it's part of the representation of the plane. You can have planes that intersect at 90 degrees, and that means they're perpendicular, so you still would need to see a box. So it's either with a symbol or with words, right? And then you can have planes intersect at non-90 degrees, okay? And so if you didn't draw that, you can use this figure over here. Now, we're going to add our postulates tomorrow. What are postulates again? You don't remember? Postulates are statements that we accept to be true. A rule or statement that we accept to be true. So this is our first postulate. Lines intersect at exactly one point. This is going to be true every time, right? This is our first postulate. And tomorrow when you see it, you're not going to memorize the number. You're going to memorize what it means. Also, the second postulate, planes intersect at exactly one line. So, add this to your notes, please. We have this dark kind of shaded plane. This would be plane STW, okay? So plane STW, it will intersect plane RST or RTS, okay? This is probably the most missed question when we start off the unit. Whenever planes intersect, that intersection is always at a line. So you might want to highlight that intersection, that line, to make sure you get it right. Okay. So plane STW intersects plane RTS at this line, line ST. Okay. Make sure we know it's a line every time. Well, there's a back, and I'm gonna leave it up there for y'all to copy. But we're gonna stop right there because you have a quiz today. Okay. All right. So if you don't get to the back after the quiz, make sure you check Edmodo. or check up here on the smartboard